Now let's see what happens if we increase our standard deviation. So instead of being 1.05, our sample standard deviation will now be 1.25. And again, I strongly recommend that you practice. You might feel like, oh my gosh, I'm doing the same thing over and over again. That's how you get good at it. That's what's going to make it easier on a quiz or a test. So my variable is still quantitative, so I'm still using x bar plus or minus 2 times s over the square root of n for my confidence interval. My x bar sample mean is still 2.23. Now my s is 1.25. My sample size n is still 150. So I'm going to take care of the division first, and when you take 1.25 over the square root of 150, you should get 0.10206. Make sure that you try it yourself. Then the next step is to multiply that by 2, and when you do, you should get 0.2041. And I will just make note that that again is the margin of error. So on this particular line, the confidence interval is written x bar statistic plus or minus margin of error. Then I'm going to do the plus and the minus. I do the minus on the left and the plus on the right. So I take my statistic and subtract the margin of error, and I take my statistic and add the margin of error. And when you do the subtraction, you should get 2.0259. When you do the addition, you should get 2.4341. And that is our confidence interval, our 95% 2SD confidence interval. Now, again, we're comparing the width. So let's go back to the original sample standard deviation of 1.05, and remember the width on that confidence interval was 0.343. Now, I've changed my standard deviation to 1.25, and what is my new width? Oy, I forgot to calculate it. Let's take the width by calculating 2.4341, the high value, minus 2.0259, the low value. And when you subtract those, you should get 0.4082. So my width, when I increased my sample standard deviation, my width also increased from 0.343 up to 0.4082. So as my sample standard deviation went up, so did my width. By the way, the margin of error has also increased. And while we're at it, let's actually calculate the midpoint of the interval. We're going to take our high value, 2.4341, plus our low value, 2.0259. After we've completed that addition, we'll divide by 2, and lo and behold, we get 2.23, our sample mean, once again. So the statistic is always at the midpoint of the interval. And then our margin of error, we could double check that by taking 2 times the width. And if you do 2 times, sorry, we got to take our width and cut it in half. I apologize, yikes. If we take our width, and divide it by 2, cut it in half, then we will get our margin of error. So if you take 0.4082, the width, and divide by 2, in fact, you will get 0.2041, which is the margin of error that we found before.